Hello, everyone. Welcome to my presentation. I'm Yingpeng from HKUSD. As you can see, I'm going to present one work entitled Disentangling Crowdfunding from Fraudfunding, a design science approach. This is a joint work with my supervisor, Professor Yang Yi. As you may know, crowdfunding platforms have emerged as an important channel for founders to collect funding for their project ideas. The crowdfunding market is expected to grow by around 200 billion US dollars in the coming 5 years, expanding at a compound annual growth rate of over 50%. However, what's accompanying the rapid market growth is the rising risk of fraud on those online crowdfunding platforms. Even though crowdfunding platforms such as GoFundMe claim that fraudulent campaigns make up less than 0.1% of all campaigns, the real rate might be much higher. For example, Paris et al. In their 2020 paper shows that the prevalence of fraud in a random sample of medical campaigns is around 10%, which is much higher than that reported by GoFundMe. Even with a low rate of fraud, considering the large volume of the launched campaigns, fraudulent campaigns are not rare at all. Fraud on crowdfunding platforms have seriously damaged the benefit of backers. According to Kumi et al. 2020 paper, backers have spent more than $30 million US on detected fraudulent campaigns. Fraud also damages the reputation of the crowdfunding platform. Therefore, fraud detection is a timely and important task. However, most previous studies are primarily focused on the questions of what factors lead to the success of crowdfunding projects, largely ignored the fraud detection tasks. Also, a few existing studies on crowdfunding fraud detection mainly utilize verbal content and general project information, largely ignored the useful information embedded in the network formed through founder-backer interactions. What's more, existing detection models are generally ad hoc, lacking a unified theoretical framework, which is important in guiding a better design of ID artifacts. Facing the limitations of existing studies, we propose a new framework guided by fraud detection theories, which could better capture the deceptive cues. Before introducing our framework, I will introduce 3 theories that are utilized in our study. The first one is information manipulation theory. It argues that when deceiving others, people play with or manipulate relevant information in myriad ways within their discourse. The second one is interpersonal deception theory. It argues that deceivers partake purposeful actions such as manipulating completeness, accuracy, and relevancy during interpersonal interactions. Third one is interaction adaptation theory. It views deception as a continuous process, and aggregated information over a period of time is more useful than a single piece of information. This is our proposed design framework following a rigorous design science paradigm. As you can see, we use the above mentioned 3 series as our kernel series. And after that, we conduct the meta requirements analysis. The purpose is to construct the different computable dimensions reflected by the fraud detection series. And after we finish the meta requirements analysis, we will conduct the meta design. There are 2 purposes of meta design. The first one is to construct the corresponding features that represent each dimension identified in the meta requirements. The second one, of course, is to design an IT system that could conduct the corresponding analysis, extracting features, train and evaluate the model, and finally, we could use the model to classify the new campaigns. And lastly, we have a testable hypothesis. Basically, we want to evaluate whether our model have the ability to extract useful features from multiple sources of information, as well as whether our proposed model have the ability to enhance fraud detection results. Therefore, we conduct incremental effects analysis, and also we compare the performance results of our proposed model with several benchmark studies. As you can see, this is our proposed system architecture. First, we crawl the project information from online crowdfunding platforms, and we use this information as our input of meta-analysis. And those meta-analysis include textual analysis, founder profile analysis, and the network formation and analysis. And then we extract the related features from those analysis. As you can see, our feature set contains two parts. The first one is the baseline, which is only contains next door feature. And second one is our proposed feature guided by the theories. They include like creator credibility, disclosure quality, engagement affinity, and so on. And after the feature extraction, we could use the training data to train our model and use the testing data to evaluate the model. And after our model is evaluated, we could use it as a model setup. And whenever there are new projects generated from the online crowdfunding platforms, we could use our feature engineering tool to extract the related features and input those features to the trained classification model, and let the model to automatically classify whether the campaign is fraud or not. Those are the proposed quantitative metrics. As you can see, overall, we propose 11 dimensions, but due to the limitation of the time, I will not go into the details of each dimension. As you can see, those dimensions include identity transparency, appropriate quantity, ease of reading and understanding, risk demonstration, communication timeliness, response relevancy, engagement volume, backer composition, pledge distribution, reward structure, and engagement affinity. And then we'll go to our evaluation set. Our empirical data comes from Kickstarter. As you can see, we have around 1,140 campaigns. And also, in order to construct the legitimate campaigns, we use a stratified sampling to select a representative amount of successful, failed, and concealed campaigns. And in total, we have around 6,000 legitimate campaigns. For each campaign, we try to collect the information about project descriptions, user profiles, backend distributions, updates, comments, and so on. And we use 4 conventional evaluation metrics to evaluate our model. They are precision, recall, F1 score, and AUC score. And also, we use tenfold cross-validation technique to evaluate the model performance. First, we will compare the baseline models with our proposed models. Basically, baseline model only uses the textual information. And following previous studies, we use 3 criteria to select the top N terms. Those 3 criteria are chi-square test, document frequency, and information gain. And we also run 4 classifiers, which are widely used in the text classification. They are auto boosting, random forest, SVM, and live base. And then we use the set of selected terms that achieve the peak performance in each of the baseline model as our baseline feature set. We term it as F0. As you can see, this is the results of our incremental effect analysis. As you can see from the table, when using only baseline feature, the model performance is not very good. After adding each set of our proposed features, the performance increases significantly across all models on all of the 4 evaluation metrics. And when incorporating the 4 proposed feature sets, the model achieves the best performance. Those results reveal the efficacy of our proposed feature sets. And of course, we also want to know whether our model could beat several benchmark methods proposed in previous studies. Therefore, we compare our model with 3 previous studies. As you can see, most of those studies use linguistic features or textual cues. As you can see from this table, our approach outperformed all these benchmark methods significantly, which also reveal the efficacy of our proposed model. Overall, our study contribute in terms of the theoretical and practical implications. First, guided by information system design theory, we propose a novel crowdfunding fraud detection framework that utilizes and integrates multiple sources of information. The evaluation results show the superior efficacy of our designed artifact. And also, our work revealed the importance of network information in terms of fraud detection in the crowdfunding context, which is largely ignored by previous studies. Lastly, in terms of practical implications, as you may know, crowdfunding platforms have spent a lot of human resources to identify the fraudulent campaigns. Our proposed system framework can help identify the fraudulent campaigns ex ante automatically. That's all about my presentation, and thank you very much for your listening.